Hi, everyone. Thanks so much for being here today. I'm Mary Kirschner. I lead customer success at Focal CXM, and I'm excited to welcome you to today's webinar on the importance of building intelligent enterprise search with Ontology. Enterprise search has come a long way, from keyword search to AI-powered semantic search. But life science organizations still need AI to understand the business context behind their enterprise knowledge. Today, we will explore how ontologies, enterprise search, and Gen AI work together to deliver more intelligent, context-aware knowledge discovery. A little housekeeping before we begin. If you have questions along the way, please put them into the QA. I'll help facilitate those questions at the end of the session. Next slide, please. All right, but why don't we go to the speaker slides, please? Wonderful, thank you. With me today, we have two of our experts. Srini Alluri is a seasoned technology leader with over 20 years of experience helping life sciences and manufacturing organizations modernize their enterprise platforms through AI, enterprise search, data, and automation. He specializes in AI-powered knowledge discovery, enterprise search, and intelligent solutions that prove productivity, compliance, and business outcomes. Manogna Bachali is a software engineer with 5 years of experience building enterprise search and AI solutions. She specializes in OpenSearch, Coveo, Seneca, Gen AI, Python, AWS, and Databricks. And she has a focus on delivering scalable intelligence search solutions for enterprise platforms. So thank you for joining us, Srini and Mano. And Srini, I'll pass this over to you to get started.
Thanks, Mary. Thanks for the introduction. Hi, all. Thanks for joining the webinar. Today, we'll be discussing about the importance of ontology for enterprise search in the life sciences industry. The agenda goes like this. We'll talk about the challenges without having ontology for enterprise search, the benefits of having it, types of ontology, and how we implemented this in real time. Next one. All right. So ontology, as a name, sounds very daunting, but underlying concepts are pretty simple. What happens is in any given domain, for example, be it financial, be it life sciences, be it any other industry, domain is the key because that's what the business understands. That's what the people who are dealing with the customers understand. Rest of the tech is a underlying bet to make the life easy. However, the terminology of domain is extremely important when you communicate to the business or the end customers. Typically, in a life sciences industry, we term the domain to be very precise as ontology. What it does is, whatever are the keywords, let's say there is a drug called Keytruda, and Keytruda is a cancer drug, and there could be a lot of other ways how we can refer to that in the market based on who is the person in the context who is talking about this drug, which means different words mean the same thing. When we say different words, to be very precise, different words related to the domain, related to life sciences. Here, if you look at it, there is a familiar example that we want to take. A drug names, if you take the leftmost one, and then all these four blue color labels mean the same thing in the life sciences world, right? However, who uses it and in which context it uses it, the word would pop up accordingly. So one official name plus one, it could be transactional name and it could be a domain name. All put together, how do we relate it for a meaningful context for the end user is the question. We solved the problem of enterprise search using semantic AI a long time back. As we evolved, we wanted to bring in, as AI is evolving, we wanted to bring in, get closer to the reasoning world. And the reasoning is more and more dependent on the ontology, the domain, basically. That's why it matters. So that is the topic of our discussion today, where we are trying to emphasize on why ontology is important when it comes to enterprise search. Next one, please. Yeah. So where plain text and keyword search fall short. So we all are familiar about semantic search, which looks up for similar kind of words and then it will pull out the meaning sort of, it will pull out the relevant chunks out of it, and we aggregate the data and project it. The basic limitation about it is there is a terminology drift. What we mean by it is the terminology that a business person is using about a drug and the terminology a lab assistant is using, they both are talking about the same thing. The lab guy would be referring to a formula, the business guy would be referring to a drug name, the commercial guy would be referring to the more popular name of the drug, let's say Keytruda, right? So few of them are talking the same thing, but you see there's a terminology drift. Similarly, the information when it gets into the documents or into the data, based on how the information is being fed, where the information might be fed, there will be a traceability gap. Let's say I'm storing the information about a cancer drug into a document, and I am also talking about Keytruda in my commercial documents. Though both of them are related, however, there's no way to match it because my semantic search would fail because there's a traceability gap. What it would result in is it would result in a disconnect knowledge, which is very expensive. And without ontology, the explainability becomes very difficult. And then obviously there are fragmented vocabularies that would add to the complexity of the problem. That is where while semantic search is great, it brings in certain limitations in order to address a larger audience in a meaningful way. Next one. All right. What is a structured vocabulary? To keep it short, what we are trying to do is we are trying to leverage the power of ontology where all the different meanings which are similar in nature based on the domain are comes under the one roof, and we provide an identity to that. While we do the similarity search, we would also look up into something called a concepts. So in ontology word, how do you pull up these documents or how do you identify the similar words is something related to a concept. Typically, two things will travel in parallel. One, your semantic search, which is fetching the meaning, plus you also have a structured concept traveling in parallel. So we are only empowering or we are going to make it more meaningful by adding ontology over the semantic search. And that is where you see there is a high precision because now with the power of ontology, you are able to look up for more meaningful information. You have explainable results. The reason being the explainability comes from more meaningful ontology keywords being part of your context, which you are feeding to your LLM. Cross-source interoperability, the same example, if my commercial is using different terminology in a document and my scientific is using a different terminology in my document, now I'm able to stitch all these documents together because of ontology. And the most important thing that cannot be ignored is this becomes a foundation for reasoning. We did a different webinar lately explaining how enterprise search has become more and more prominent in the AI world because the AI needs context, and the context comes from enterprise search. Ontology is giving you more meaningful context. So we are becoming more and more relevant by adding ontology to the enterprise search. Next slide, please. Right? So this is a transformation of from left to right, and on to the right stands the ontology, which means if you layer it in a way, on the bottom you have list of all the terms, and then comes the taxonomy, which is a little meaningful, where you create hierarchy of the words. Then comes thesaurus. Based on the hierarchy, you try to group meaning words which have similar meanings. Now ontology adds a layer to it, which is a domain knowledge. Next one. So there are different ontologies that are managed or maintained in life sciences. Each one of them has got a different purpose. It is very evident from the slide. If at all you want to go for um, clinical ontologies, then you go for HPO. If you have gen functions, you have to go for Go. However, it depends on what is your enterprise search is going to cater to, which segment is it going to cater to. You don't have to uh, really create an ontology layer for everything, but whatever is meaningful for you, you probably create that ontology. Next one. All right. So there are three stages. Very oversimplified view of how this whole works together. The first stage is you build a knowledge base. How do we build the knowledge base? We build the knowledge base based on the standard medical vocabularies, and you bring in uniform data. You create a uniform data set. Then once you have the uniform data set where you identify the ontologies, which means typically concepts, and then you have them ready, then you ingest the documents which are coming from multiple sources. Could be Veeva, could be Salesforce, could be other documents which are whichever all regulatory and all these documents put together. Once you have all these documents ingested into this, now what is happening is I'm now able to tag a document, tag a document to my knowledge base. And that is how both of them are getting related in the stage two. The more meaning is coming in the stage three, where I'm trying to pull the documents and then pass it to my LLM for reasoning. And that is where the whole power of ontology is surfacing. And at the stage three, if you see the reasoning with ontology and without ontology, you can easily find the maximum difference the way the LLM is responding. So that's the power of passing domain knowledge along with your semantic search knowledge to an enterprise search, to an LLM for reasoning. Next slide, please. All right. So what do you mean by an ontology aware question? In the sense, my enterprise search is also considering or factoring ontology when it is answering the questions. That's what it means. In the total 5-step process, the first one is whenever you give a question, what our enterprise search engine would do is it will extract the keywords from the question. Let's say you're asking what is the best drug for cancer, and is Keytruda the best drug for cancer? If this is the question you have passed, it will extract the words like cancer, Keytruda, best, whatever it thinks, or it would think that this keyword might fetch the results. It will fetch all the keywords, put them into sequence, and then start looking for information. That is a traditional enterprise search. Now, what we have introduced, step two. Now we go and connect to a concept. Concept is again, to keep it simple, all the related domain words for cancer and the drugs, everything grouped together is called one concept, and it'll have a specific ID. And this ID would get into the map to the ontology. ID would be mapped to the key terms, and then it would then get to an embed. So as the documents get embedded, the questions also get embedded. That's when at step number 4, you see there's a hybrid retrieval where I identified the keyword search plus whatever I got from the concepts. I did a lookup, and in collaboration with my keyword search plus the ontology search, I did a retrieval document. If you do a little bit of small experimentation by not having ontology versus ontology, probably you might see a 32, the confidence score of the response from LLM would vary anywhere between between 45 to 60% in our experience. Yeah, next one, please. Next one. All right. So this is a high-level architecture on how the overall flow works. The first one that you do is the standard vocabularies, like whatever your ontology types that we have seen. We are going to that ontology types, and we are trying to create concepts out of it. And all these concepts are going to map into an embedding. And once these embeddings are stored, right, you see that ontology knowledge base where I'm unifying all the ontology knowledge bases. What I mean by that is, as we said, right, there are multiple frameworks for ontologies. All these ontologies are being pulled and unified into one ontology knowledge base. What happens on the top, what you see here is a document source coming in, document source is action. This is a regular process, nothing new. And you do a chunking, and from chunking, you have entity detection, which means I'm trying to identify entities related. So conceptually, what we shifted from a traditional keyword matching to an entity matching. From entity detection, what I do, I come to the concepts. The concepts are again related ontologies, what we are grouped one ID concept, and gets attached to the embeddings that is part of my, and from there you do a meanings embedding. One is generated. Here we are having meaning plus search. This is what we are talking about. That's the reason we are trying to emphasize on how important is ontology. From here, we have an hybrid retrieval from here, and then from hybrid retrieval, you go to an answer generation. So the dark blue colored are extremely important. These are the new things that got introduced in the overall workflow. And then finally, based on these answers, you get a you get a you get a meaningful reasoning from the LLM. Yeah, next slide, please. All right. Now coming to the stage one, if you talk about how are we generating the knowledge base, the first step to it is you build a knowledge base by turning scattered vocabularies into one resource. That's where you create the source, the vocabularies all coming together. Once you have all identified all the vocabularies, then you normalize into one format. What we mean by that is this is where the concept of concept comes in, where you're grouping all domain specific words or keywords under one hood, under one ID, and then you are indexing them for fast lookup. This is stage one that we do. Next one. All right. Stage two, once you have your ontology getting indexed, the next thing that you'll do is you extract every document that you read, you understand and get it tagged. What does it take? Step one, you extract the document, you check the document. Then these dark blue boxes represent the newly introduced functions where we are detecting entities within those chunks, and then we are resolving concepts from those entities. What we mean by that is, let's say an entity could be like a drug name, entity could be a disease name. So what we do is once you identify a disease name, right, like disease, and then you go and identify the related concepts to it. When you go to the concept, you find more relevant keywords, domain specific under one concept. Once you identify these concepts, everything will get embedded, right? And then once the embedded meaning is there, you store ready to search data in the vector database. The key enrichment step here is everything that is being detected by your ontology concepts plus your meaning, they travel together to provide you more risk. All right, next one. Stage three, the user comes in and then user asks a question. It's the same understanding as a document, which means when we ask a question, the question would obviously not having all the ontology related keywords in it, or it will not have anything beyond the phrase that the user has entered. We start adding more meaning to the question. We start do the discovery phase of the question, augment the context of the question, and then we go to our index where we indexed our ontologies, we indexed our documents, we stitch together all the information, and then we retrieve by meaning and concept. So this is the key thing, the step three, where we are retrieving by concept and meaning, and then we generate a grounded answer when it comes to. The reason we're calling it as grounded is as we provide more domain ontology specific knowledge, which is very common, that's when the LLM would understand or build its context around it and try to give you a grounded answer rather than going only by the semantic meaning. Next one. So these are a few lessons from the real world while we implement it for our customers. One, not every match is a good match. Obviously, all these search is depends on the machine learning algorithm, and by concept, the machine learning algorithms learn over a period of time. You might not get accurate and personalized relevant results in one single shot. You have to fine tune. We have observability in place. As and when the results are coming out, the persona is getting understood by the ML. The kind of questions will be understood, and then only it becomes more and more relevant. Probably from 60% to 90%, it would go in a period of 3 to 4 months. It depends on how many times you're using the system and how much of variety of questions you're asking to the system. Second, scale changes everything. So today, probably you're pulling the information from Viva Medcoms, Viva Promats, and down the line, you want to have OneDrive integrations, you want to pull the data from real world evidence. All this would add to the volume of the index data. As the volume increases, obviously the scale would be a challenge, but there are variety of techniques. How do you sustain the scale? And we have done it in real time. Resilience is obviously an important design pattern, which we have taken care in our enterprise search implementations. Traceability is extremely important. We have implemented our portal, which Manogna is going to demo in a minute, where every user who has come in, the audit trace starts, and we'll track every single activity that the user has performed, what documents he has used, what kind of questions he has asked, what are the relevant results that would have come. Are we confining the user results based on the role that he has, based on the access he has? So all that is pretty much configurable within the existing portal that we have built. Next one. Yeah. While we move on to the demo, two ways to look at the answer that you get. One, a semantic search, and ontology-aware search. That's where we are trying to use the right terminology. So ontology-aware search is more powerful. That's the emphasis we want to bring in. And the overall architecture of our application that we have built, our solution that we have built, we have multiple accelerators that we have built, while in the backend for all search activities and the machine learning activities are being handed over to OpenSearch. We are tightly coupled with OpenSearch for those activities. In the front end, we have built 100% configurable open source Angular application where you can configure, customize it as you wish. And then in the backend, what we also built is wherever there are no out-of-box connectors, we also built out-of-the-box connect. We also built some custom connectors using which you can pull data, both structured and unstructured data. So typically, the enterprise solution that we have built not only deals with structured data, it is capable of dealing with unstructured data, and it has got the power of giving you the results based on semantic search plus ontology search, and it gives you best user experience in terms of getting the relevant results and producing them in front of the user. Next one. So a few things to remember from the discussion that we had so far. One concept, one ID is the fundamental or the basis for your ontology. Explainable, not just accurate, is the concept that comes in when you bring in the reasoning in place. Meaning plus concepts together, I've been stating it multiple times, that makes your enterprise search more powerful. A foundation to build on, we are building on the foundation of ontology. So that's what makes this enterprise search more relevant for business users and customers. Next one. All right. With this information, what we will do is we'll go to the live demo where my colleague Manogna would be showing you our enterprise search platform. And then we'll walk you through a simple use case and show you the different and ontology search. With that, Mano, over to you.
Yeah, thank you, Srini, for the overview on ontology. Now let me share my screen and quickly walk you through the enterprise search portal. Yeah. So this is our enterprise search portal where at the top of the portal we have a single unified search bar where the user can ask a question and get the response. So below the search bar, we have multiple tabs which define multiple sources. To the top right, we have out-of-the-box connectors through which enterprise repositories like Veeva, Salesforce, SharePoint can be connected in minutes. On the left, we have filters. You can narrow down your results by title or any other metadata. So now let's quickly check on the Viva connector. So once the configurations like email, password, domain, and along with the query, when we give all these details, the documents get indexed into the open search. In the same way, for the rest of the accelerators, we just provide the configuration details specific to that source, and the documents are ingested and made searchable in the portal. So now let's see the difference between the semantic search and the ontology search with a quick small example. So let me search with the question what are the risks and benefits of rotavirus vaccination. So what happens in this semantic search is this search entirely relies on the content of the retrieved documents. It uses vector embeddings to find documents that are semantically similar to the user's query and then generates an answer by summarizing the relevant information from these documents. As you can see in this example, it explains the benefits and risks of rotavirus vaccinations because these facts were present in the retrieved documents. However, it doesn't understand that rotavirus vaccination is a standardized medical concept or related to any medical ontology. In the same way, let's check on the ontology search. Let's see with the same question again, let's see how the ontology search behaves. So here in the ontology search really comes down to what's happening behind the scenes. So in the ontology search, when the user questions when the user asks any questions, it detects the key terms in it. As just now Srini mentioned, we will be detecting the key terms from the question asked. Then those terms are then matched against the standard medical vocabularies like mesh, mondo, RX norm, etc. So each term gets tied to one official recognized concept, not just a string of text. This is the exact same detection logic that was already run on all our documents when they were indexed. So both sides, like the question and the documents, are speaking the same standardized language. This is why, so if you see in the same example again for the same question, it identifies the rotavirus vaccination, rotavirus, and the interception along with their respective IDs. Uh, Respective IDs like concept IDs. These are the concept IDs which are associated with this rotavirus vaccinations. It then combines the concept knowledge with the retrieved documents with not just matching but with the exact shared concepts to produce a concept aware response. As a result, the answer is not just based on document evidence, it's enriched with standardized medical terminology, concept normalization, and biomedical context. This makes the response more structured, explainable, and aligned with the life sciences standards. To sum it up, the ontology search doesn't just find similar text, it understands the concepts behind it. So as you can see, once we get the response here, these are the documents from where the response have been pulled from and along with the results fallout. So with that, I'll hand it back over for the Q&A. Thank you.
Yeah, thank you. And one last point before getting Q&A is, as we see, right, with the results being tied up with the ontology with more meanings, when you have to you're building your AI agents and you want to perform some activities or next best actions based on the reasoning that is in place, the enterprise search context, which is ontology driven, becomes extremely important. And that is how your agents, which are autonomous, would be more grounded. All right.
All right. Well, thank you, Srini and Mano, for your sharing your expertise today. Really enjoyed that discussion. We do have a couple of questions. I'll just get right into those. So the first one is, we already have semantic search. Why do we need an ontology?
Yeah. So ontology is becoming more and more relevant with the AI advancements that we are having. People are not looking just for keyword search, pull me a document, but people are looking for that information which would be guided with more reasoning. Example could be what are side effects of Keytruda could be more and more relevant when you tie it up with ontology and you feed it for reasoning to an LLM. So the more meaningful results would come out. So that's where the ontology takes a prominence.
Okay, thank you. The next one is, can ontology work with our existing systems?
So when we say existing systems, yes. For example, you're using an Azure AI search or using an open search, then what we can do is we can build a layer of ontology and then we try to index it along with your vector database. Yes, we can do that.
And so if they're using Claude for AI search, can we build an ontology on top of that?
No, see, underlying ontology comes into play with the vector databases. It could be anything. It could be Claude, it could be OpenAI, anything. Your LLMs are not directly leveraging your vector databases. The AI in between, the AI agent in between, would first go to the vector databases, which are ontology embedded, which means you have already embedded the ontology concepts into the vector database, and then it pulls out the relevant chunks from that, and then it calls your Claude or OpenAI. So it's a precursor to your LLM calls.
How does ontology improve generative AI and RAG?
Yeah, absolutely. So RAG is the foundation where your concepts are all being indexed. And whenever a question is being asked, you're going to look up for a meaning and for an ontology. So the meaning chunks plus your ontology concepts chunks would be passed in the context of the LLM. And that is where LLM, while it understands the semantic meaning, it would also get a lot of understanding about the real world context from the ontology and provide you a better reasoning.
Okay, thank you. Next question is, where should organizations start?
A good question. I think the organization first should start with a blueprint where they would like to understand who are the user personas. For example, if you're in life sciences, if you're talking about sales reps, or you're talking about MSLs, or you're talking about medical affairs teams, the fundamental reason why you are saying you should start with identifying the user persona is because pretty much everything else determines or goes by the persona. Example, for a salesperson, the systems from which the data you have to pull would be a commercial system like Veeva Vault. If you're talking about a medical affairs team, the system from which you probably pull the data would be a medical affairs system, or a medcom system. And then if it is MSL, probably you go to commercial plus medical affairs. So fundamentally, the user persona is driving the systems from which you pull the data. And once your the data is being indexed, on top of it, ontology, obviously, we are mapping into it and indexing into it. The questions would vary based on the persona. So that is the reason. If somebody has to start, please do a blueprinting of who is your user persona and then identify the systems that from which you have to pull the data.
Okay, great, thank you. And then last question, how do you measure the success of an enterprise search initiative?
Perfect. The success of enterprise search can be measured in multiple ways. One is obviously the productivity that you gain. Example, today, if a sales rep has got a question around what could be the best document you can pull out and share it to an HCP, then probably he has to go to a Viva commercial and do a lookup, and then he has to identify and understand only based on his own understanding and intelligence. The turnaround time could be probably a 24 hours or 16 hours, or how much time the sales rep is doing a due diligence. However, with enterprise search, you can simply come in and key in a question. The enterprise search would act on behalf of the sales rep and provide him with the documentation. One example. The most important example that I would like to quote is if there is a MSL, and typically the job of an MSL is whenever they receive a question from a HCP, two things are important: the efficacy of the response they are providing and the SLA within which they are responding. In this case, the enterprise search is the most important tool for them, where the key in a question that came from the HCP. Enterprise search in combination with ontology gives more context. It will go through the multiple systems which are data which is being indexed, pull the indexes out of it and the chunks out of it, and then gives it to reasoning to the LLM. This is how a structured response would be given back, structured, and more importantly, genuine information will be provided to the HCPs within a stipulated amount of time. So that is the power of enterprise search.
Great. Well, thank you. All right, I think that's it for today, folks. Thank you all for your time. Thank you again, Srini and Mano. And those of you who are here or those that signed up online will receive a link shortly for the webinar so you can take a look. Have a great day.
Thank you all. Thanks for
Thank you
joining.
all.